All right, so graphing number 6. So go ahead.
So it's 3 cosine 2 pi x.
Good. Awesome. Okay, there are 3 things I need to know for any graph. What's one of those things?
Amplitude.
Amplitude. Think about your waves, people. Think about your waves. So I'm going to go ahead and I'm going to draw my graph. And is there a vertical shift?
No.
No. So it's going to go up to what and down to what?
3 and negative 3.
Up to 3, goes down to negative 3. Because I can say my amplitude is 3. If I had had a vertical shift of 2 here, what would that have done to my x-axis?
Moved it up 2.
It would take this whole picture and it would have shifted it vertically. If it was positive 2, it'd be up 2. If it was negative 2, it'd be negative 2. All right, next. What else do I care about?
Period.
My period, and to find the period, I need to know my v value. So we're going to remember here that for a math definition, period is 2 pi over v. It's the only formula you really need to know.
Look at that.
So what's my v?
2 pi. That's
1.
great.
2 pi. So my period is 2 pi over 2 pi, which is
1.
1. That's easy. So that means that after 1 unit, I have 1 full cycle of my wave. Now pause. What's the other thing that I need to make sure there is no
Phase shift.
Oh, phase
There's no
shift.
C value.
Phase shift. There's no C value, so is there a phase shift?
No.
No, it has not been shifted left or right, so that means it starts on the origin. Or in the case of a cosine function, it starts at a maximum. Everyone, do not make the dumb mistake of assuming that every graph is the sine graph. Look at those letters to make sure that if you have to start at a max, start at a max, or if it's sine, you start at the x-intercept. So the last piece here now is I need to have some guidance here. So if this is 1 full period, it starts at a max and ends at a max. How do I find what each section is? Yeah, I take my period or my wavelength and I divide by 4. So if I take my wavelength, which is the same thing as my period, divide by 4, I get 1 over 4. So I'm just going to leave it as a fraction. That means that I have a fourth. And then I have 2 fourths, which is the same thing as 1/2. Then I have 3 fourths. Then I have 4 fourths, which is 1. Do I need to see these on your graph for credit?
Yeah.
Mm-hmm. And now it's easy. Max to x-intercept to min to x-intercept to max. Here's my wave. Now, sometimes teachers are like, oh, I want you to grab 2 full cycles of the wave. If you can do 1 full cycle, then I trust that you can do 2 full cycles and continue the process. So do not worry about graphing multiple cycles of it. As long as I see 1 full cycle and everything's correct, you're good. Great question. I want to pause to see if there are any follow-up questions to anything we just did. Do we see the connection to our project?
Yeah.
Same exact thing. Bless you. All right, other questions here?
13.
13, great. Yeah, good, good. I was hoping someone else had one. Good.
No, I didn't get 13.
Yeah. Hey, this is like, everyone remember in every math class you probably ever had where people said, listen, math is foundational. You need something for like future units and you can't just forget it. You need to still know it. This problem, well, I'm saying to you now. This problem is one of those problems because secant is something we dealt with last semester. And last year a little bit, but last semester. So we have to remember what secant is. So we have the secant of the arctangent of 3x. Okay, so first off, rewind. The secant of theta is equal to 1 over what? Cosine. Good. I'm going to keep that little fact over here to the side. Right? That's something we learned last semester and last year that we're going to remember. Remember, S's and C's like each other. That's why it's 1 over cosine. So, okay, this is a problem like our Demandado Jordanos. What do I first have to do?
You have to
Set equals theta. Let theta equal what? Arctan of 3x.
Sorry.
Good. Now I can get all cute. I'm going to take tangent on both sides. You don't really have to show this stuff. So I say the tangent of theta equals, that's a terrible color choice, equals about 3x. Now, is 3x a special angle, a special like number on the unit circle? No. So I'm going to draw a triangle. And now how do I label it? Tangent is equal to what over what?
Sine over cosine.
Sine over cosine, or with SOHCAHTOA, it's equal to opposite over adjacent. So that means that, oh, but I only have one number. What can I put that over?
1.
Over 1. Yeah, 3x is the same as 3x over 1. So that means that the opposite side is 3x. The adjacent side is 1. That's a tricky point right there. A lot of people, if they don't forget to draw the triangle, they forget that anything can be put as something over 1. Now, what do I have to do? Solve for this guy right here. Perfect. So I'm just going to label this as C. How do I solve it? Pythagorean theorem. Some of you can just do that in your head. Just write for me what it's equal to. Others might want to show the work, and that's okay. So 1 squared plus 3x. Oh, be careful here, people. 3x squared. What did I do with the 3x? Yeah, I have to square the whole thing. So I have c squared equals 1 plus 9x squared. And what do I have to do? Square root both sides. Square root. Square root. So c is equal to plus or minus the square root of 1 plus 9x squared. So I'm going to label that up here. Very, very good point. So, keep in mind, the triangle is supposed to represent the unit circle. On the unit circle, I care about the positive values of these trig functions and I care about the negative values. So, I consider this triangle not a physical triangle per se, but something used to represent algebra. As a result, we go with the plus or minus. Okay, so now let's think about this. The secant is 1 over the cosine of theta. So that means that I'm going to take whatever the cosine of this thing is, and I'm going to probably find its reciprocal. So let's go ahead and do this real quick. What is the cosine of theta equal to? 1 over what?
The secant.
Yeah. Cosine of theta is adjacent over hypotenuse. So that means that the secant of theta is equal to hypotenuse over adjacent. Just do that step here to make it easy for yourself. Because I'm going back up to here, right? The idea is to find the secant of theta. I know that's h over a. So now I can finally say for my final answer, I love this problem. Plus or minus square root of 1 plus 9x squared. All over, what's my a? 1. So it's really, it's just that. Good. Now people, if I'm looking at this, you can think about it if you have questions. If I'm looking at this, I'm thinking like, man, oh, probably a point to realize that substitution, probably like 2 points to get the correct picture. Maybe another 3 points to get that thing right there. Maybe another point to realize what the secant is. And then maybe another point for the final answer. So we're talking like an 8, 9, 10 point problem here. But remember, I grade on partial credit. So if you forget a step, just leave what you have and you'll at least get some credit for it. Come back to it later. Pish? Bosh. Good. Other questions? Looks 5. Thank you, Chloe. Yeah, good. Number 5. Okay, number 5. M of x
What size is it?
equals -5 sine pi over 4x plus 1. Good. Alright, so everyone, this is the whole point of the entire unit. Can I graph a trig function? Exactly like our tsunamis. So let's follow the same process. Keep in mind, on the test, am I going to give you a vertical shift? Probably not. Vertical shifts do not make sense with trig functions. They just don't. They just don't. So I'm not going to incorporate them. We've done some practice problems with vertical shifts, but since they don't really matter, I'm not going to assess you on them. And since our project didn't have them, I'm not going to assess you on them. So we have a phase shift. How do I not have a phase shift? I have that C value up there. I have an amplitude, which is good. Okay. Do I have a period that's been changed? Next, I have a B value. And what does this negative sign do? Flips over the x-axis. Good. So let's just keep all those transformations in mind as we go through this. Okay, first is my amplitude. What's my amplitude? Yeah, 2 ways to think about it. I'm going to think about it in a positive version. Okay, I'm going to think about it with respect to the absolute value. So my amplitude is 5. That means it goes up to 5 and down to -5. So let's go ahead and graph this sucker. Okay, next. Let's go ahead and find my period. Period is equal to what over what?
2 pi over 4.
So 2 pi over 4. Do not let fractions be the death of you. Bless you. If I have a fraction over a fraction, I keep the top the same and I flip the bottom. So that means that I have times 4 over pi. What happens to pi's? Cancel, and I get 8. If you put this in a calculator, it's probably not going to give you 8. It'll give you like 7.9999999 because it estimates pi. If you have 7.9999999, that means that I'm going to probably count a point off because that's not the exact value. The exact value is 8. Now, if the calculator does it correct, then great. I don't care. All right, so 8. What does that mean on my graph?
Over right.
Yeah, it goes 8 units before it repeats. 8 full units until it repeats. It's the wavelength of the period. Good. Okay, what's the last thing I have to find?
Phase shift.
Phase shift. Okay, let's go ahead and figure this guy out. I'm going to do this another cover. In order to find the phase shift, I have to change my equation a little bit. How do I have to change it?
Back to the
I have to backtrack that pi over 4. So I'm going to do this below here with some side work. So let's see. I have -5 sine of pi over 4 times x plus 1 over pi over 4. That looks ugly. So let's go ahead and simplify this a little bit more. -5 sine of pi over 4 times, let's see. I have a fraction over a fraction. I keep the top the same and I multiply by the bottom flipped, the reciprocal. So this is just x plus 4 over pi. Now remember, normally I say I have one exact answers, but now we're graphing. You're graphing by hand, so you don't have an exact answer. So I'm probably going to want to know what this decimal is. So can someone divide 4 by pi for me?
I got
1.27?
Yeah.
Okay. Now why is my phase shift negative 1.27?
Because it's plus and everything is the opposite.
Yeah, just like a horizontal shift. If it's plus a number, I shift left that many units. So my phase shift is about negative 1.27. And again, I got this by dividing 4 by pi. All right, so let's graph. Am I okay so far with y'all?
Yeah.
Did amplitude, did period, did phase shift. Okay, so the phase shift tells me what about my wave? Where it does what? Where it starts. Perfect. So that means I'm going to go left, negative 1.27 units, and I'm going to put it down there. Yes, Charles?
Wouldn't you have to subtract that from 8 too?
We're going to get there. So now remember, I have all this space. I would really like some guidance for my little slashes. So to find how far apart each section of the wave is, what do I do with my period? I divide it by 4. This turns out really nice. So my period divided by 4 means that it's 8 divided by 4, which is 2. So that means after every 2 units, my wave starts a new section. So if it starts at the next intercept, it's at a maximum after 2 units. After 2 more units, it's at the next intercept. After 2 more units, it's at the min. After 2 more units, it's at the next intercept. So I have my starting value, and I have to keep adding the number 2. So someone have a calculator ready. What is negative 1.27 plus 2?
0.27.
I think it's like 0.73. Thank you. Negative 1.27 plus 2. Huh?
It's 0.83. I think.
Oh,
Because I subtracted it from
but
8.
83 would make it 2.1.
Well, we'll get to that number here eventually. Here, Charles, I'm just starting from the beginning going forward rather than starting the end going backwards. So I added 2 to negative 1.27. Because 2 is how far apart each section of the wave is. I want to pause. I want to make sure we're okay with this little arithmetic problem. Yes.
Oh, okay.
So how did I get 0.73? I added 2 to negative 1.27. Why did I add 2?
Because that's your little.
How far apart each section is. Good. Great. We got through it, team. So then I have to keep adding 2. What's that plus 2? Oh, now it's easy. That plus 2.
4.7.
That plus 2.
6.7.
Good. Okay, again, I'm doing that to give some stability to my wave. So now I can finally graph. The 8 was our original guideline. Everything has been shifted left, negative 1.27. So I'll bet that 8 minus 1.27 is 6.73. So I'm using the orange here to guide myself, the orange. So think about now the last piece. I don't want you to lose silly points. Have I accounted for my amplitude?
Yeah.
Yes. Have I accounted for my period?
Yeah.
My phase shift?
Yeah.
There's one thing I'm missing. What is it?
It's negative.
Yeah, my negative. So that means that it flips everything over the x-axis. So instead of going x-intercept to max, it's x-intercept to min, to a trough. Back down to the x-intercept. Back up to a maximum. Back down to an x-intercept. I now have my wave.
That's the ugliest graph I've ever made in my life.
Will I probably give you a wave that is more like that on the test?
Yeah.
Yes. Because that is what our project was. That is what we're assessing. Yeah. Okay, so Ethan asked a really good clarifying question here again. You said, Mr. A, when we divide 4 by pi, why do we get negative 1.27? We don't get negative 1.27 when we divide the numbers. We get a positive. The reason why this number is negative is because it represents a shift left and right. Anything that's x plus a number shifts it left that much. So this would be the same thing as me saying the horizontal shift is negative 1.27. Good question. Other questions? Yeah. I have 1 divided by that fraction, so I keep the top the same and I flip the denominator. 1 times anything is that. All right. So I do want to be mindful of physics review as well. We have now covered every single concept on this review guide. From now on, it would just be reiterating the same thing. Probably by the end of the bell, I will have a review guide posted and on Echo, so you can check it over the weekend. I would like you, go ahead, sorry. Yeah, yep, sorry, that's what I meant. I would like you all to take a quick, 4-minute break, and then when you come back, I believe we're going to probably hear from Julia's presentation with Alan, and then we're going to do physics review. So please go ahead and take a break.